Chapter 1, Introduction to Algebra. A vista into history from UCS Louisiana EDU, and here's the link. In the 7th and 8th centuries, the Arabs, united by Mohammed, conquered the land from India across northern Africa to Spain. In the following centuries, through the 14th century, they pursued the arts and sciences and were responsible for most of the scientific advances made in the West. Although the language was Arabic, many of the scholars were Greeks, Christians, Persians, or Jews. Their most valuable contribution was the preservation of Greek learning through the Middle Ages, and it is through their translations that much of what we know today about the Greeks became available. In addition, they made original contributions of their own. They took over and improved the Hindu numbers, symbols, and the idea of positional notation, very important, position. The ones, the tens, the hundred, the thousand, and so on. The numerals, the Hindu-Arabic system of numeration, and the algorithms for operating with them were transmitted to Europe around 1200 and are in the use throughout the world today. Like Hindus, the Arabs worked freely with irrationals. However, they took a backward step in rejecting negative numbers in spite of having learned of them from the Hindus. You make sure you learn positive and negative numbers. You should know them already. In algebra, the Arabs contributed first of all the name. The word algebra came from the title of a textbook in the subject, Hisab al-Jabr wal Mukabala, written about 830 by the astronomer, mathematician Muhammad ibn Musa al-Khwarizmi. This title is sometimes translated as restoring the simplification or as transposition and cancellation. Our word algorithm is a corruption of al-Khwarizmi's name. The algebra of the Arabs was entirely rhetorical. They could solve quadratic equations, recognizing two solutions, possibly irrational, but usually rejected negative solutions. The poet, mathematician Omar Khayyam, from 1050 to 1130, made significant contributions to the solution of cubic equations by geometric methods involving the intersection of conics. You will learn about conics in intermediate algebra and beyond. Conics came from cone. Like the Ophantus and the Hindis, the Arabs also worked with indeterminate equations. Here are other links if you're interested. Algebra.com, helpalgebra.com, freemathhelp.com, ehow.com, mathforum.org, and so on. Think of algebra basically as arithmetic. So if you don't know arithmetic, good luck in algebra. You're going to need more than luck. Using unknown numbers and variables. The variable x stands for an unknown, whereas 3 is understood to be just 3, 1, 2, 3. X is a locked X box which contains a number. So whenever you come across X or Y or Z, think of a box. It's a locked box. Your object is to unlock the box and find the number inside. In algebra, it is important to write algebraic expressions neatly. A bad example, what is this? Did you mean to have the fraction bar extended over the 6, or did you mean just the 4 and 5 being in the numerator, and to this fraction you add 6? Or did you mean just 4 over 7, to which you add 5 plus 6? I don't like slashes for division, but this is normally interpreted as you do the division first, you get a 3 and then a 4. Some people intended to be 6 over 8, and they should write parentheses around the 2 and the 4, or they should write it as a fraction like this, 6 divided by the product of 6 and 4. And even this fraction bar is a little bit too short. If you mean 6 over 2 times 4, write it this way. If you want the square root, how far does the square root sign extend? Did you just mean it to be the square root of 124, and this dot, is that a decimal or is it a multiplication sign times 25? Or did you mean to take the square root of 144 times 25? Or the square root of 144, which is 12 multiplied by 25? Be careful how you write in arithmetic. This is very, very important. Don't be sloppy. You'll regret it. And then some vocabulary. A variable, a letter like x, represents a number. An algebraic expression is a collection of symbols other than an equal sign or a greater than or less than sign would turn it into an inequality. 2x plus 3 is an algebraic expression. No equal sign here. So you cannot solve that. You may be able to simplify it, but not solve it. X minus 3 over the square root of pi is an expression. An equation contains an equal sign, and it relates two expressions. You have a right member, you have a left member. So again, be careful how you write mathematics. A word on homework. You are responsible for your homework. You do as much as you need or as little as you think you can get away with, and getting away with it is not a good idea. You make sure you can really do it. Study an example in the text by writing it out on paper. Get to the point where you can reproduce the example without referring to any source, including the solution. Then you will be ready to start the homework. While doing homework, do not copy an example statement that you just read from an example with the new numbers from the homework problem. You cannot consult examples from the text when you take an exam. Okay. Suppose this is a solution. You have the statement of the solution, you have solution, and you have the steps of the solution. Cover up the solution completely. On a new piece of paper, see if you can write out the solution that is covered. If you get stuck at the beginning, uncover one line. Copy it, see if you can continue. If not, uncover the second line, see if you can continue. If you are not able to reproduce this in full without keeping this covered completely, then go back after you have copied the solution. Go back, cover the entire solution again on a new piece of paper, reproduce the solution. You get stuck again, that's okay. You copy the entire solution and start over again. Keep this up until you can really reproduce the solution. Proceed like that for every example, and then do the homework. You will no longer have to flip through the pages, work with a solution when you are doing the homework. You know you can do the problems. You will solve the examples. Take what I'm telling you to heart.